Hello and welcome to EduMath. In this video, we are going to look at the measures of central tendency. And if you are new here at EduMath, consider subscribing and hitting that notification bell such that you are notified whenever we make a new upload. For now, let's get started. Now under here, we shall be looking at the mean, the mode, and the median. So we are going to start by looking at each of these tendencies. So let's explore more about the mean, which is denoted with x bar. Mean x bar can be found in two ways. We shall have mean being equal to the summation fx divided by summation f. This is when the assumed or the working mean has not been given to you. But when the working mean is given, we can go ahead to find the actual mean x bar from the formula. It assumed mean plus summation fd divided by summation f, where f, this here is the frequency, then this small x, that is the midpoint of the group. Then this a here, capital A, is the assumed mean. This smaller d, that is the deviation. And the d is got from the expression of smaller x, the midpoint of the group, minus the assumed mean. So that's about the mean. Number 2, we are going to look at how we find the mode for the grouped data. We know that mode is a number or element that appears most, meaning that mode is determined based on the frequency. So by formula we have mode for the grouped data being equal to, I will denote this as L1, but we are going to define them plus D1 over D1 plus D2, everything times C. So where L1, this is the lower class boundary of the model class. D1, this here is the model frequency minus the frequency before. D2 is the model frequency minus the frequency after. Then this capital C, this is the class width of our model class. So this formula is the formula we are going to be using to finding the mode for the grouped data. Next, we are going to see how to find the median. Median is the value which is in the middle of the distribution when it is arranged in order. The order can be either ascending or descending. Now for the case of grouped data, we always observe classes being arranged from a smaller class to the bigger class. So that implies that this data has been already organized in ascending way. So the formula for finding the median, this is going to be equal to L1 plus we have N over 2 minus cumulative frequency before CFB all over the frequency of the median class times the class width of the median class. Now where N is equal to summation F CFB, this is the cumulative frequency before, FM, this is the frequency of the median class, then that C is the class width of the median class. Now having seen the formulas which we are going to be using, for median we have this, for mode we are going to have this, and then lastly for mean we have two formulas. We have this here, and when the assumed mean has been given to us, we have this other formula. Now in this video, we may not be able to look at everything and exhaust it, but we shall be looking at them in the subsequent videos. For now, let us get started with an example. They need us to find the mean weight, the model weight, and the median weight. Now we shall start by drawing a table. You know that mean is equal to summation fx all over summation f. Mode is equal to L1 plus we have D1 for D1 plus D2 times the class width. Then median is equal to L1 plus N all over 2 minus cumulative frequency before over frequency of the median class times C. Now, basing on our formula, it means that we shall be having columns of X, Fx, and then cumulative frequency. Cumulative frequency will come in to help us find the median, and then Fx will come in to help us find the mean. Then we know that mode solely depends on frequency, which we have already. So for now, let's get started by having this table redrawn. Now we need to go ahead and include in the headings like X. We shall have Fx here. We shall have the cumulative frequency, and then we shall have to get the class boundaries. But here, remember here we say that this X stands in for the midpoint of the group. So for the first group, to get X here, we shall get 20 plus 29 divided by 2. Midpoint of this group is like taking the average of these two values, and then we shall be getting 24.5. 24.5. Now to get the rest of these other values, provided our class width here is uniform, they can be got easily by using the class width. But how do we find the class width? Class width, which is the same as class size, which is the same as class interval, capital C is equal to the upper class boundary minus the lower class boundary, right? So our task here is on now getting the class boundaries. We know that this data here is to 0 decimal place. You can see this is 20, it has no decimal place. This is 29, it has no decimal place. And now we can go ahead to find the tolerance error. Tolerance error will help us to determine what to add on the upper limit and what to take away from the lower limit. So the tolerance error is going to be equal to half times 10 power negative n. For us this time we don't have the number of decimal places, we have 0. So this is going to be a half times 10 power 0. And finally, we shall be adding on the upper limit 0.5 and taking away 0.5 from the lower limit as we get back here in the table. So we now need to get here the class boundaries. Take away 0.5, which is determined by the tolerance error. So this will be 19.5 to 29.5. This will be now 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, and so on up to 99.5. Now, since the class width here is uniform, what we are going to do, we are going to choose on any class and then we use it to calculate the class width. So picking on this class here, class width capital C is going to be 79.5 minus 69.5, and C is going to be equal to 10. Now, in the previous video, we saw that class widths come in only to make our data to be continuous. So we can observe that this data here is now continuous, unlike for this case here where we had the class limits. There is a gap here between 29 and 30. There is a gap of 1. Now, we know our class width as being 10, so we shall keep adding 10 on the 24.5 here to get the rest of the midpoints. But if you're not conversant with that, you can keep on taking the average here. For now, we are going to be adding the class width. So plus 10, which is our class width, get 34.5, plus 10, you get 44.5, plus 10, we get 54.5, plus 10, 64.5, plus 10 here, get 74.5, plus 10 here, we get 84.5, 94.5 plus 10 here, get 94.5. Alright, so the next thing is we are going to get f times x, fx, f times x. Alright, so our values of fx, 4 times 24.5, here we get the 98 on our calculators. 6 times 34.5, here we are getting 207, and so on for the rest of these other values. Just keep on multiplying here. So right now we have filled in the column for fx. We need to get summation fx. We need to add all these values. So from our calculator, we shall be getting 2420. We also need summation f. So from our calculator, if you happen to add all these values, we shall be getting 40 there. Alright, we are remaining with the column of cumulative frequency. So we put here a 4. We need to accumulate this. To get the next value, we shall just say 4 plus 6, which gives us a 10 here. 10 plus 2, we get a 12. 12 plus 5, 17. 17 plus 7, we get 24. 24 plus 8, we get 32. 32 plus 5, we get 37. 37 plus 3, we are getting the 40. So that's how we get the cumulative frequency. The next thing is now to use this table here to calculate the 3 measures of central tendency. We are going to start with the mean. So mean x bar is equal to summation fx over summation f. Our summation fx is 2420 divided by summation f. Summation f is 40 here. So when we compute this using our calculators, we shall have to get mean as 60.5. This is the mean x bar. Next, we need to calculate for the mode. Mode is by formula L1 plus we have D1 over D1 plus D2 times C. Our C is equal to 10 now. Now, we have to be able, first of all, to identify the model class. Okay, model class is a class with the highest frequency. So we go under the column of frequency. The highest frequency here is 8. So our model class here is going to be 70 to 79. And from here, L1, which is the lower class boundary of the model class, is 69.5. We know that C is equal to 10. Now we need to get D1, and we need to also get D2. D1 is the model frequency minus frequency before. Our model frequency is 8. And the frequency before is 7. So we shall have 8 minus 7, which gives us a 1. D2 is the model frequency, which is 8, minus the frequency after. Frequency after is 5, which is now giving us a 3. So from here we now see therefore mod is equal to 69.5 plus have 1 divided by 1 plus 3 times the class width, which is 10. So when you compute this is 69.5 plus 1 all over 4 times 10. So this here is 69.5 plus 2.5. When you compute this, we shall have to get the mode as 72. Next, we need to compute the median. Median is equal to L1 plus we have N all over 2 minus cumulative frequency before over the frequency of the median class times the class width. Now we say that median is the value in the middle of the distribution when that distribution has been arranged in either ascending or descending order. For now, we can see that our data here is arranged in ascending order. We can see that from the smaller class to the bigger class. So we start identifying the median class. So to identify the median class, we shall need the median position, which is going to be got from this term here, n all over 2 value. And after getting the median position, we shall go to the cumulative frequency column, trade it from there, as cumulative frequency shows the positions of our values. So our capital N is equal to summation F, and summation F is 40 all over 2 value, which gives us the 20th value. So this here is the median position. Now the median position is not the median. It helps us to find the median. So we need to read the 20th value from the cumulative frequency. So the 20th value lies within here. So from here, that means we can be able to get L1, the lower class boundary of the median class, as that 59.5. The cumulative frequency before is 17, and the frequency of the median class is 7. CFB is 17. Then the frequency of the median class is 7. Then we know capital C is 10, right? So now the next thing is we are going to substitute this information here in the formula here. So we get started. Median is now equal to L1 is 59.5 plus n over 2, but n over 2 is now 20, minus cumulative frequency before, CFB 17, divided by the frequency of the median class, which is 7. Then times the class width, which is 10. This here is 59.5 plus, this becomes 3 all over 7 times 10. So when you compute this on our calculator, we shall be able to get median as 63.8. This is to 1 decimal place. Alright, I would like to thank you, my dear viewer, who has been with me up to this point. In this video, we have looked at how to find the 3 measures of central tendency, but for data which is of whole numbers. In the next video, we shall be looking at how to find the 3 measures of central tendency, but for the data with decimal points. But hey, before we leave, I would like to leave you with one number that you're going to practice. And also you can pause a video or you can replay the video to get more clarity. So we can pen down this question here and then we give it a trial. And my dear viewer, if you are new, consider subscribing at EduMath for more videos of this kind. Then you can also be able to pause the video to copy down the question. You can replay the videos whatsoever. For now, from us EduMath, we say thank you so much for being part of us, and we wish you the best.